Good morning, everybody. This is going to be really hard after Edward Snowden's speech, Lynn Ulbricht's keynote, and Nozomi's summary. But I will try to follow up on all these principles that try to cover our privacy, freedom issues with one of the last remaining concerns that we may have in the Bitcoin ecosystem, which is the lack of open source and Bitcoin mining. Let me ask you a question. Do you guys know why we need mining except for minting the coins? Generally, yeah. One person? OK. 2, 3, 4. OK. So basically, the mining is the precondition to have a secure blockchain, right? It's the thing that makes our Bitcoin free and permissionless, because we don't have to ask any entity to confirm our transactions, to roll them back, and so on. So we should realize that it's really important to understand what is mining the Bitcoin and why we should have a look at it and check if it's really so transparent and open source that if it's not doing something else that you were expecting. How do we get to this point? The Bitcoin history started somewhere like 2009, right? And essentially, at that time, we used to have all the open source code available. We had the Bitcoin node. It was actually able to mine Bitcoins at that time, because the original idea of Satoshi was that you have one CPU, one vote. This started changing very quickly, because Bitcoin has an embedded algorithm that incentivizes people to join the network and mint the coins. However, since the network is controlling the inflation rate, it fights back the miners by increasing the network difficulty. So it's in best intentions of the miners to improve their mining algorithms and make them more efficient and fast. So originally, we had this situation where there was the CPU, and we had a software called CG Miner, which was fully transparent, open source, auditable, and the miner was essentially this piece of software and your laptop or your machine or whatever. This started changing in the next phase when people discovered, oh, we could probably try to compile a SHA-256 kernel into a GPU and see if it's performing better. So this was the next generation of the miners. And it was still CG Miner, but I'm sure that there were some groups that had some more efficient kernels for their GPUs, and some of them had not that efficient ones. But still, there was no questionable thing, because nothing obliges you to publish your work. You can use it to your own advantage. There's no problem with that. The next stage in mining, and you see the CG miner like slowly disappearing, we had the FPGAs, which was the test bed for the final stage when we had dedicated devices. With the FPGAs, the situation was still pretty good, because it was a commodity hardware. You can buy an FPGA board. If you're skilled enough, you can write your FPGA code, and then you can control the FPGA with CG Miner. CG Miner still has quite a few backends for FPGA mining. However, all this stuff got obsoleted by this. They're called ASICs. The ASIC abbreviation means application-specific integrated circuit. So essentially, these devices contain dedicated chips that had been previously prototyped on the FPGAs. And that's when the miner devices got professionalized, and there were companies actually entering the industry and trying to make business of it. This is not a problem. This is a fact. But the problem is that there is like nothing much left of the CG miner except for the mining front end that talks to the mining servers out there, to the pools and so on. But the device itself is already quite complex, because it's usually a fully fledged computer. So it contains many more components than just the CG miner package. And you may want to ask yourself like what it is doing in the background except for mining. Is it like really mining all the time for me? Or is it using a little bit of the mining shares to its advantage? I don't know. Oh, there's an end appearing there. Essentially, where we got today is we don't have a transparency and auditability in the mining firmware that's running out there. And we had quite a few incidents that demonstrate the need for changing this. As one example, there was a famous incident called Endbleed, where the miners were actually calling home to the manufacturer, and it allowed remote control of the devices. I mean, it has been advertised that it's actually a feature, not a malicious bug. But if that feature got exploited massively without people knowing, since the majority of these devices were actually, that was the mass of the hash rate in the ecosystem, we could have serious problems securing our blockchain if you can shut down the miners, right? Another example, which was not like malicious in a way that you could like shut down something, but there were devices that had features that allowed some miners to run in a more energy-safe way. So you could save up to 13% energy. For those who are from the industry, it's called ASIC boost. And the problem is not with the technology itself, it's a feature, but the problem is they didn't tell you. They would tell you, oh, it cannot do ASIC boost. Bullshit. It was able to do it, and we published a paper last year about this problem, and it actually made the manufacturer publish a fixed part of their firmware, which is the part that is running in the control board on the FPGA that's controlling the hash boards, that magically had this feature enabled that was not breaking the mining shares anymore. So that's the second example, and I like to say it as an example from real life. Like when you buy a car and the manufacturer tells you, oh, you can do reverse. You have to push your car by hand to your garage. Is that okay? Would you like the car? Well, if you have no other option, you would buy the car, right? But what if they tell you after 2 years, oh, by the way, if you press this button, I give you a firmware update, you can actually do reverse. So all that work is wasted, right? And that wasting 13% of like worth energy on this, it could be a serious issue. I don't know, people don't care. And then we have like a latest updates that actually try to take away control from the people. And it's actually a pretty serious issue because we have groups of people who are actually forming like hackers groups. And they try to jailbreak their firmware so that they can control it again. They cannot SSH to the miners anymore. These are like the latest manufacturer features. So these are like 3 examples that I personally, and we personally find really puzzling that should be addressed. There should be a slide in there. Oh, sorry. So what can we do about it? Well, it's easy, right? Cypherpunks write code. So let's get back to the code and start an initiative that would be like the central point. If I'm a manufacturer of an arbitrary device, your toaster, and I want to run Linux kernel on it, I go to linuxkernel.org, I download it, and I write the software for my toaster, and I publish it usually because I don't want to maintain the sources all the time. And then I keep selling my toasters, right? But the users who don't like how the toaster behaves, they can fix it, they can change it, whatever. So let's start the initiative. And we actually took the step already, and it's called BrainsOS. We did it last year in September, shortly before we were publishing the paper about the ASIC boost problem. And then the main motivation was actually to show that it is possible to have a central point that's providing a consistent open source package. So not just the CG miner, but everything you need to have to run on your miner. Because you want to be sure that it's mining to the full performance. What if it's not? So this is my last message. There was somebody out there online saying, if you don't own your keys, it's not your Bitcoin. So if you don't own your firmware, it is not your miner. It's not your hardware. Thank you.